We want to find the area between the two curves, 2 cosine of x and 2 sine of x. Notice it helps to know what this graph looks like. So sine of x is this pink curve, cosine of x is this orange curve, and the area we want between them occurs here. So we're probably going to be doing the integral of top minus bottom. In this case, the top function is 2 sine of x, and in this case, the bottom function is 2 cosine of x. The next problem is figuring out what the bounds are going to be on this integral. Well, cosine and sine of x have the same value of square root of 2 over 2 at pi over 4. And it's true that they have the same absolute value at 3 pi over 4, but one's negative and one's positive. That's in quadrant 2. So as a quick refresher, this is pi over 4. That's where cosine and sine have the same value of root 2 over 2. This is 3 pi over 4, where sine has positive root 2 over 2, but cosine's negative root 2 over 2, so they don't intersect there. But at 5 pi over 4, both cosine and sine are negative, and they're negative root 2 over 2. So this is our other intersection at 5 pi over 4. So these are going to be our bounds of the integral. We're going to put pi over 4 here, and we're going to put 5 pi over 4 above here. The integral of 2 sine of x is negative 2 cosine of x. The integral of negative 2 cosine of x is negative 2 sine of x, and now we're going to plug in our bounds. As I've said, sine of pi over 4 and cosine of pi over 4, those give us root 2 over 2, and the cosine and the sine of 5 pi over 4 give us negative root 2 over 2. So I'm going to plug all these things in. This is going to be negative 2 times negative root 2 over 2. This is because I'm plugging in 5 pi over 4. Minus 2 times negative root 2 over 2. That's all I get when I plug in the upper bound. Now I'm going to plug in my lower bound of pi over 4. This is going to give me negative 2. Cosine of pi over 4 is root 2 over 2. Sine of pi over 4 is also root 2 over 2. Well, make sure I put the 2 there. And when I collect all these terms together, I end up getting positive 4 root 2, and that is my final answer. I just want to quickly show you that these negatives cancel. This 2's cancel, this negative cancels with that negative, that 2 cancels with that 2, so I get root 2 plus root 2, so far 2 root 2. And a lot of the same thing happens over here. These 2's cancel, these negatives cancel, and so I end up getting 2 root 2 plus 2 root 2, or a final answer of 4 root 2.